In this video, we'll be looking at the following 3 variable acceleration questions. As an added bonus, we'll initially talk about how we can seamlessly transition between equations that involve displacement, velocity, and acceleration. Let's get to it. As you probably know, acceleration is known as the change in velocity over the change in time. If we assign a as the variable for acceleration and v as the variable for velocity, since dv by dt represents the change in velocity over the change in time, therefore a is dv by dt, i.e. acceleration is the derivative of velocity with respect to time t. In a similar manner, as you probably know, velocity is known as the change in displacement over the change in time. If we assign x as the variable for displacement, since dx by dt represents the change in displacement over the change in time, therefore v is dx by dt, i.e. velocity is the derivative of displacement with respect to time t. Furthermore, we can represent a relationship between displacement, velocity, and acceleration in terms of the following diagram. So we can easily move down this chain by using differentiation to go from displacement to velocity or from velocity to acceleration, meaning we can integrate to move up this chain to go from acceleration to velocity or from velocity to displacement. And this diagram will come very handy for us when completing any variable acceleration questions. In this video, units for displacement, velocity, and acceleration will be meters, meters per second, and meters per second squared respectively. However, we can apply similar methods if we use different units. Let's start our first question. When tackling the following question, since this is a variable acceleration question because velocity is a function of time, the first step is to write down the relationship between displacement, velocity, and acceleration on the side. The second step is to decide whether we need to differentiate to get acceleration, integrate to get displacement, or use the original velocity equation. Since we start with velocity and the question asks, find the times when the particle is at instantaneous rest, rest refers to velocity being 0, so we don't need to integrate or differentiate the equation. All we need to do now is set our velocity equation equal to 0. Then the third step is to find the values of t. Since this is a quadratic expression, I'm assuming you already know how to factorize, so we'll do that right away. Therefore, the solutions to this equation are t equals 1/3 and 3 seconds. Those are the 2 times when the particle is at rest. When tackling the following question, since this is a variable acceleration question because displacement is a function of time, the first step is to write down the relationship between displacement, velocity, and acceleration on the side. The second step is to decide whether we need to differentiate, integrate, or use the original displacement equation. And since we're dealing with displacement and the question wants us to find velocity, therefore we need to differentiate the original equation. I'm assuming you know how to differentiate this, but we want to take the power of t down, then take 1 away from that power. So upon differentiating x with respect to t, we get v equals 9t squared minus 10. Then the third step is to substitute the value of t is 3 into the new velocity equation. So we get velocity equaling 9 times 3 squared minus 10, which equals 81 minus 10, which equals 71. So the velocity is 71 meters per second. When tackling the following question, since this is a variable acceleration question because acceleration is a function of time, the first step is to write down the relationship between displacement, velocity, and acceleration on the side. The second step is to decide whether we need to differentiate, integrate, or use the original acceleration equation. And since we start with acceleration and the question wants us to find the velocity equation, therefore we need to integrate the original equation. I'm assuming you know how to integrate this, but we want to add 1 to the power of t, then divide by that new power. And upon integrating a with respect to t, we get v equals t to the power of 4 minus 5t squared plus c. Then the third step is to substitute the initial conditions we're provided with in order to find c. And since we have an initial velocity of 6 meters per second, the word initial means that we have the velocity of the particle right at the start. And in general, when starting something, the start time will be 0 since that's the beginning. Therefore, v is 6 when t is 0. And upon substituting these values, we attain 6 equals 0 to the power of 4 times 5 times 0 squared plus c. On the right side of the equation, this simplifies to be just c, therefore c is 6. So the velocity equation equals t to the power of 4 minus 5t squared plus 6. So that's going to do it. I hope you managed to get something out of today's video. Don't forget to subscribe for more free content just like this, and turn on all notifications so you don't miss any uploads from this channel. If you have any questions, just pop them in the comment section below. Thanks for watching, and I'll catch you in the next video.